Good morning, guys. So this is for group 2 here, and your learning target is I can determine whether a table, set of points, or a mapping represents a function. So we're going to start by talking about the difference between relations and functions, and then look specifically at tables, points, or mappings. And you want to take some good notes here because you're going to be teaching this to other people in a little while. So first, relations and functions, those are considered some of the most important topics in algebra, like this little blurb says here. And that's because you're going to use them in, pre-calc and calculus and trig and any of the higher math classes from here on out. And we're going to continue to use them for the rest of the year in this class. So they become really, really important, mostly because we can take something that's real world, that's a real situation, and we can model it after a function. So we can create a graph, we can create a table, we can create a list of points that work for this particular situation, and it helps us get more information from that or make a prediction potentially. So there are two sort of concepts we're going to talk about. The relations are like a bigger group. So you can see they're in this green circle here. And a function is a subset of the relations, okay? So a function is nestled inside of the relation. So all functions are relations, but not all relations are functions, all right? A relation is simply anything that connects an input and an output. So when we talk about functions, we always have something we're putting in, something we're pulling out of that. And an ordered pair is usually what we represent some of the things as, a point, right, on your graph, or a point that's been given to you. And so the input we generally represent as x and the output as y. So a relation is really anything that relates or shows a relationship between inputs and outputs, or x's and y's, okay? So anything we have that has x's and y's paired together, that would be a relation. Doesn't have to follow any rules, it just has to have x's and y's paired together. A function is more specific than that, all right? So a function is a relation where there's only one output for each input, or only one y for every x, okay? So that really means when a value or an x is inputted, we only get one y value. All right, so if we inputted an x and we ended up with multiple y values, that's just a relation. But if we input an x and there's only one potential y value we could get, then that's a function. So it's a much stronger statement, and it helps us to be a little more specific or a little more clear when we're discussing these types of relationships. If we know there's only one possible answer when we put something in, that's great. If it's just a relation and there's multiple answers for just one input, that can be a little confusing, right? So functions are a little bit clearer, they're a little bit more easy to work with. So let's look at some examples. What should we look for to determine if the points represent a function? Well, let's check out the inputs, which again are usually the x's, and the outputs. Okay, so, and those are usually the y's. So we want, for every input, we want to get its own output, all right? So when we input -3, 7 was the output. Only one possible answer there. When we input -1, 5 was the output. When we input 0, -2 was the output. If I stopped right there, those 3 points would create a function. But let's say, when I input -5, I get 9, or when I input -5, I can also get 3, right? Well, this is the same input, but two different outputs. So anytime that happens, This is not a function, okay? One of the things it might be easiest to do is to list your table as a set of points. To do that, we would use the set brace, and then we would just go ahead and list them out. So -3, 7, -1, 5, 0, -2, -5, 9, and run out of room, -5, 3, right? So that's just a set of points. Anytime we have two x values that are repeated and they go with a different y value, that makes it not a function. Okay, so you want to look for x values that repeat or inputs that repeat. Any repeating inputs that have different outputs. All right, that's all we're looking for. Are there any inputs that give us the same, that give us different outputs? All right, so let's check this second one here. This is, they're telling us it's going to be a function, but let's check why. -3 is my input, 0 is my output. I see no other -3s in the x column, so that should tell me, okay, then I only have, this input is only going with one output. -1 is its own input, and it gives me -2. I don't get anything else from inputting -1. 0 is going to give me 3. Again, I don't get anything else from inputting 0. 4 gives me -1, and 5 gives me -3. So all of these were different inputs. So that tells me, yes, it's a function. Okay. And one thing we should mention is you can have repeating outputs. That's okay. Doesn't confuse us to have outputs that are the same as long as we only get one of them when we input a number. All right. And that's what this is showing, or one of the things we can see here. So here we put in 1 and we got out 5. We have a repeating x value. Again, here we put in 1, but we got the same input out, right? We got 5 out. So if we did this, then there's no problem here. There's no different output for the same input, right? If I were going to list out all of the points in this relation, it would be 1 and 5, and then we have another 1 and 5. I don't have to write it twice. And the next one is 3 and -8. Well, if those are the exact same point, there's no problem here. This one input gives me one output, and that's okay. All right. So it's okay to have repeating inputs if the outputs also repeat. All right. Okay to repeat inputs if outputs are the same. All right. So lastly, let's look here and just take a peek. So we can represent any of these things as tables, graphs, mappings, a list of points. Again, sometimes it's easiest if you take your values and you put them in a list of points, a set of points. So if I do it for that first one here, we'd have -2, 1. And then next we have -2, 3. Well, already I'm seeing a problem, right? -2 is paired with two different outputs, right? This one input has two different outputs. So that would be not a function. And I don't even have to check the rest of them because that's where it failed, all right? You'll talk about graphs with a different group here, but all I did was take these points and plot them on a graph. And then a mapping is the last thing that we want to talk about. So a mapping is where you can have x's and y's, or inputs and outputs, and they're connected with arrows, okay? So this first point, -2, I should use a different color, sorry. Let's go -2, that has an arrow to 1, so that would make the point -2, 1. Then we also have the point -2 with an arrow to 3, so that would make the point -2, 3. Then we have a point 0 that connects to -3. We have 1 that connects to +4, and 3 that connects to +1. And I'll put that in a set because this is a set of ordered pairs. So again, we can see now that there are two inputs that are the same that give me two different outputs, right? You can also see that here if you have an input with 2 or more lines coming from it. It's not a function. All right, so that would be for your mappings, tables, and list of ordered pairs. Look and see if your inputs get repeated, if they go with a different output.